Morning to one and all. That application was currently working associate professor in Alcindra College of Engineering and Technology. Welcome back to today lecture series of engineering systems. Today we are going to discuss about Fourier transform of periodic system. So already we know the Fourier transform is applicable for both periodic and non-periodic signals. So far in the previous classes, we have seen how to obtain Fourier transform of non-periodic signal. Now, if we take a periodic signal, already there is an existence for existence transform is Fourier series. So the same concept it is extended in Fourier transform also. So that's why we consider the Fourier series formula that any signal is going to be extended in expanded in Fourier series concept. The formula is x of t is equal to summation of k equal to minus infinity plus infinity x of k into e power j k omega naught t. We know here omega naught t, omega naught is a 2 pi f naught. F naught is equal to 1 by t naught. So omega naught is equal to 2 pi by t naught. Now for the equation, above equation, if you apply Fourier transform on both sides. So Fourier transform of x of t is x of omega. Here there is no any time function. So as it is, you write summation of k equal to minus infinity x of k. E power j k omega naught t Fourier transform you need to write. So e power j k omega naught t Fourier transform is obtained from again from frequency shifting property, because there is a e power j, you need to write this one e power j k omega naught t into 1. We know Fourier transform of 1 is 2 pi into delta of omega. So according to the frequency shifting property, here 1 into e power j k omega naught t. Already we know Fourier transform of 1 is 2 pi delta of omega. So 1 into e power j k omega naught t Fourier transform is 2 pi into delta of omega. Instead of here omega naught, we have a k omega naught. So just to replace omega with omega minus k omega naught, and you substitute in this equation. Now x of omega is equal to k equal to minus infinity x of k into 2 pi into delta of omega minus k omega. Rearrange these terms. X of omega is equal to 2 pi into k equal to minus infinity x of k into delta of omega minus k omega. So it is the standard formula for any periodic signal. Now you observe one thing here. In the left side, there is a x of omega. Omega means it is a continuous. The spectrum of Fourier transform is a continuous spectrum. But if you observe in right side, there is a delta function. So the concept of delta function is it is exist only at particular value. So there is a k. K is also from, it is an integer here. So the spectrum of Fourier series already we know it is a line spectrum, or it is a discrete spectrum. So the discrete spectrum here we are going to be obtained from this delta function. Now, for example, if we take one example here, the example is obtain the Fourier transform of impulse train or periodic impulse train as shown figure below. You see the signal, it is a periodic impulse train. and its time period is t naught. The impulses are repeated with a fundamental period t naught from minus infinity to plus infinity. So it is a periodic signal with fundamental period t naught. So we are going to apply Fourier transform for this. The direct formula x of omega is equal to 2 pi into summation of k equal to minus infinity x of k into delta of omega minus k omega naught. In this formula, we are going to be calculate x of k. So x of k, we know Fourier series formula x of k is equal to 1 divided by t naught into integral 0 to t naught x of t into e power minus j k omega naught t into dt. So you write that formula x of k, and in that formula x of k integral 0 to t naught x of t into e power minus j k omega naught t. This x of t signal within this duration 0 to t naught, we have only one impulse. We have only one impulse. So x of t is here. We are going to be replaced with a delta of t. Impulse means we know delta function. It exists only at time t equal to 0. So within this formula, 1 by t naught, integral 0 to t naught, x of t is a delta of t into e power minus j k omega naught into t2. So within this entire interval, 0 to t naught, the delta function is going to be exist only at time t equal to 0. So delta of 0 is 1 and e power minus j k omega naught t into 0 is also 1. So x of k, we are going to get 1 by t naught. Here is given straightly, but this x of k is obtained from Fourier series form. So you substitute this x 1 by t naught here. So it anyway it is a constant. You write outside 2 pi by t naught. You know it is a omega naught. So summation of k equal to minus infinity delta of omega minus k omega naught. Now, in order to show the difference between Fourier transform spectrum and Fourier series spectrum or periodic signal spectrum, non-periodic signal spectrum. Already we have seen in the previous problems, non-periodic signal spectrum is a continuous spectrum. Now, while we're coming for periodic signal spectrum, if you observe from the delta function, k takes here different values of integer. It is including 0, plus 1, plus 2, plus 3, and so on, minus 1, minus 2, minus 3, and so on up to minus infinity. So, for example, I was substituting here k equal to 0. Whenever k equal to 0, there is a delta of omega. This delta of omega means delta function existing only at omega equal to 0 and corresponding amplitude is omega naught. Similarly, if you substitute k equal to 1, delta of omega minus omega naught, it is exist at omega equal to omega naught. Omega equal to k equal to 2 omega naught. It is on positive side. Similarly, coming for negative values of k equal to minus 1, you will get delta of omega plus omega naught. So this delta of omega plus omega naught is existing at omega equal to minus omega naught, and corresponding amplitude is omega naught. So if you see the spectrum of this periodic signal, it is like a Fourier series spectrum. So from this, the conclusion is whether it is a periodic signal, whether it is a non-periodic signal, Fourier transform is going to be applied successfully. It is the advantage of Fourier transform compared with the Fourier series. Thank you. We will see you next.